everyone. Thank you so much. So it's my pleasure to introduce today Dr. Scott Hale and Ashkan Kazemi, two speakers who will be presenting. And to introduce Scott Hale first, he's an associate professor and senior research fellow at the Oxford Internet Institute, the OII, and he's the director of research at Medan, and he's a fellow at the Alan Turing Institute. His cross-disciplinary research focuses on enhancing equitable access to quality information. Scott develops and applies new techniques in the computational social sciences and to social science questions, and puts the results into practice with industry and policy partners. He's particularly interested in multilingual natural language processing, computational linguistics, mobilization and collective action, agenda setting, which has a lot of interest in the School of Journalism and Media, which I'm associated with, and misinformation, and has a strong track record in building tools and teaching programs that enable wider access to new methods and forms of data. Ashkan Kazemi is a fourth-year PhD candidate in the Language and Information Technology LIT lab at the Computer Science and Engineering Department at the University of Michigan. He works with his advisor, Rada Mihalka, on natural language processing and applications and studying social media, and broadly computational social science. His PhD focus is on using NLP to develop methods for understanding and responding to misinformation within both English and, importantly, non-English speaking communities. Ashkan is an organizer for ACL Year-Round Mentorship, a program that provides mentorship to students interested in NLP research from around the world, and has served in the program committee of EMNLP, ACL, and the NAACL conferences in the past. Their talk is entitled Claim Matching Tiplines and Collaboration for Effective Misinformation Response. Thank you both for joining Good Systems today for this talk. We eagerly await it.
Thank you. It's a pleasure to be here. We're really excited to be sharing the research. As Ashkan gets the slides up, I'm Scott. I'm going to lead us off, and I'll hand over to Ashkan partway through as well to talk about this joint work that we've been doing over the last year and a half or so. So just a bit of scene setting. I think we hear about misinformation quite a bit in the media. We hear about it as this challenge that's all out there, but I want to bring some perspective to that and to say that not all misinformation is equally pressing. A lot of content online is simply somebody getting something wrong, and it may not be particularly problematic. And so, an example of this is, UNESCO declares some country's national anthem the world's best. Not true, but not particularly harmful. And I find this sort of pagoda of harms from Full Fact, the independent fact-checking organization in the UK, a quite helpful metric. I think as we think about things that affect democracy, it becomes more concerning. And then we've seen scams and economic harms, and probably what we're most acquainted with is sort of public health crisis and the quote-unquote infodemic associated there. I think increasingly we might think about climate denial and climate misinformation also as sort of posing one of these highest risk threats, because ultimately, if we can't agree on what the information is, what the facts are, what the consensus is, it becomes really hard to cooperate and tackle some of these pressing problems. So platforms aren't sitting idly by. They are trying to work on this, at least to some extent. And I think when you look at what platforms are doing, for those that have access to their content, there's a number of tools they're trying to look at. They're searching for unusual spreading patterns. They're examining reactions using proxies like controversy, looking at the most popular content, and also trying to see if there's sort of repeats of things that have already been fact-checked. Facebook probably has one of the most active programs, and I've clicked too many times, but there you go. It sort of screens content. They have an employee third-party fact-checking agencies. They have internal tooling. that flags up posts for those fact checkers to look at, and then they screen content that independent fact checkers have reported. I think that maybe works for a corporation at the size of Meta. And certainly there's still much more to do. But I think there's even more challenges as we move to other platforms, and particularly when we think about end-to-end encrypted platforms, Line, Telegram, Signal, WhatsApp as well. And when we start moving outside of English, because English is the one language where we probably have the best computational linguistics and NLP tools. It's the language in which we probably have the most fact checkers and sort of human eyes looking at things, audiences flagging content, etc. And so I think what we've been really working on is thinking about how do we reach some of these less well-served audiences, right? So people who are on these end-to-end encrypted platforms and or are accessing content in less common or at least less well-resourced languages. They may actually be very common in many cases. So the technology nonprofit that I work with, Midan, has been building tools for about 15 years to support journalism and fact-checking. But over the last 2 years has been evolving this idea of tiplines, essentially crowdsourcing potentially problematic content from audiences of media organizations and fact checkers by meeting audiences on the platforms that they're already using. And so a tip line looks essentially, we have tip line partners now. It's sort of growing every year. And now there's over 17 partners operating tip lines on WhatsApp. They're listed here. And there's some additional partners who have tip lines on Viber or Facebook Messenger as well. And so sending content to a tip line looks just like chatting to another contact on social media. People often forward in a piece of content, add a little bit of commentary. And then what we do on the tip line side is we don't automatically fact check anything. At the moment, we're leaving that entirely to human fact checkers to actually assess content and put it in context. But what we do with algorithmic work is to look through all the existing fact checks. And in many cases, we can say, the thing you sent, there's already a substantially similar item and a fact check about it. Here it is. And so if we have a fact check for a related piece of content, we can serve that back straight away. And if not, the content gets enqueued into a workflow system. And this is what that workflow system looks like for fact checkers on the reverse end. So it's a web-based tool called Check. And we can see things like the number of requests or number of suggested matches, similar matches, how many times it's been shared on other platforms, etc. This is a sort of demo page, so the numbers are very low, but some of those, you'll see, it's been requested 100 times coming in, right? And then there's a way by which fact checkers can add structured data and produce those sort of visual assets that I was showing just a moment ago. And then anyone who previously requested this item but hadn't received a response before will get the fact check at that point. And anyone else who requests a very similar item going forward will get the fact check instantly. So this is the basic idea of tip lines. And part of my role, I guess, as director of research at Midan is to bring some academic rigor and questions to this. So there was an opportunity in 2019, which was the first time Midan had supported a tip line, which ran during the 2019 Indian elections. It was hosted on WhatsApp, run by Proto in pop-up newsroom. And it turned out by happenstance that Kiran Garamella, that time at MIT, now at Rutgers, had also been collecting content around the Indian election. And Kiran had been collecting content by scraping the web looking for join links to WhatsApp groups. And so we had two very different data sets, both related to WhatsApp and the content flowing around the elections in India, but from two different perspectives. And so we teamed up together and with Ashkan, Devin, and Gautam, we were able to sort of investigate well, what were tip lines finding? How did they compare to this sort of large scale scraping of public, quote unquote, groups on WhatsApp? I want to pause for a moment and say that WhatsApp in India is probably a bit of a different animal than it is in the United States. So WhatsApp has a huge following in India. It's pre-installed on many mobile phones. It's often 0 rated, so people can get on very easily. And there's these groups that pretty much everyone is joining. Whenever I talk to Indian colleagues, they're like, "Oh yeah, I'm a member of all these different WhatsApp groups." And so information is often flowing, from person to person and group to group on the platform. And so using these two data sets, we wanted to tackle these research questions around what sort of content was coming into tip lines. Were they effective at actually discovering sort of the most popular content vis-a-vis what was being found in these larger groups that were being scraped? What sort of content was there? And what were the sort of tools that we needed to do this? I won't hold you in suspense. It's not a mystery game. So I'll say that, what we ultimately end up finding is that a large proportion of the viral content shared in public groups also appeared on the tip lines. And quite surprising to me, we found that the tip lines were often capturing this content earlier than it was being shared in some of the public groups. We have another part that we're not going to really talk about today, but we also looked at all the fact checks that were being authored by Indian fact-checking organizations during the time. And the overlap that we found between those and either the WhatsApp public groups or the tip line was fairly low. And so I think it gives us a hint that while there is content that goes across platforms, there's also platform-specific elements to this, even if that's simply in the formatting or presentation of them. So a few notes on the data. As I say, this came during the Indian elections in 2019. The data we have is from March to June, and the elections took place during 6 weeks. It sort of moved geographically apart across parts of the country. The data we're going to talk about is primarily WhatsApp, both the scraped groups as well as the tip line. In the paper, we also talk about these fact checks authored by Indian fact-checking organizations, as well as ShareChat, an image sharing network similar to Instagram that's very popular in India. So these are just the data numbers to give you a sense. The tip line is much smaller, naturally so, right? The scraped data is sort of all of the messages being sent in these larger groups. The tip line is crowdsourced content. It's simply what people flag up for discussion. So with that, I'm going to hand over. Last slide, sorry. In the methods we'll use, we'll say a lot more about those, and you'll hear about them, but image matching and text matching, as well as clustering methods. And so with that, I'll hand over to Ashkan for some more depth on this.
Yeah, sorry, I was taking back control for the slides. Hi, everyone. I am Ashkan Kazemi, and I'm a PhD candidate at the University of Michigan. And I completed this work over a collaboration with Scott and Midan during the past 1.5 years ago. And so we want to get into more detail on the specifics of these tip lines. And so we specifically wanted to know how effective these tip lines are for fact-checking encrypted social media. So effectiveness really depends on how you define it, right? And there are many ways that you can define effectiveness for a tip line, but we thought that these three important dimensions are the ones that we wanted to look at. So the first one is coverage, or basically how much of the content, how much of the discussion on public WhatsApp groups is being submitted to the tip line for fact checking. The second dimension is timeliness, or how fast this content is being discovered by the tip line. And lastly, we also care about popular content specifically because those are just the ones that we really want to sort of put a stop to, and especially if there are misinformation. So we also wanted to measure these two dimensions for popular content as well, and see how tip lines specifically are effective for sort of capturing and how quick they can capture popular content. And so we first look at coverage. And so let me first explain how these charts were produced. So what we did was we did this sort of analysis, which I will get to more details in the second study that we will talk about. But basically, we came up with some methods for text and images to group the similar ones. So texts that are making similar claims together, and we sort of clustered these images and texts, and then we counted all the times that the text messages or the images in each cluster were sort of shared on these public groups. And then based on the number of times that they were shared, we sort of put them in these buckets. So like shared between 2 to 10 times, shared between 11 to 100 times, shared over 100 times. And yeah, so we did this separately for images and texts. The x-axis refers to buckets of images or texts that are sort of shared a number of times. And then the y-axis is the percentage of the content also appearing on the tip lines. We find that the more viral content, which is content that is shared over 100 times, is meaningfully captured by the tip line. And that is, over 67% of popular images and 23% of popular text messages in the Indian WhatsApp groups were also submitted to the tip line. Now, I know that this number is lower for all content, but something to note is that fact checkers are usually mostly interested in checking prevalent content, and they would actually want to avoid fact-checking fringe claims because they want to prevent amplifying them. So we don't think this is necessarily a huge issue. Now, while coverage of content is essential for any system that wants to sort of uncover misinformation on end-to-end encrypted social media, we also think that timeliness should be something that we should study. And you have probably heard of this famous study from Vossouri et al. That basically says misinformation spreads much faster, as much as 6 times faster than real news. And so realistically speaking, if tip lines want to be a viable solution for content moderation on these platforms, they also need to be timely in their coverage as well. And so in our second analysis, we look at the time difference between the first time a post appeared in the public groups and when it was first submitted to the tip line. Now, the x-axis is the difference in days. And so the positive difference means that the content appeared on the tip line first before spreading more widely on the public groups. And negative values show that the tip lines received the post after it was spread on those groups. And the y-axis shows the fraction of the posts that were sent to the groups, or that were sent to the tip lines after at most X days past their submission date to the tip line. Now, we do this analysis for images, texts, and URLs, and we find that the vast majority of the viral content, so that's 85% of texts, 80% of images, and 70% of URLs, roughly speaking, were submitted to the tip line before they spread widely on WhatsApp public groups. This number is lower for all content, but the same principle applies. So from these analyses, we find that tip lines have the potential to stop viral misinformation in time because they capture a meaningful portion of the popular content before they are widely spread. Now, there are more analysis in our paper, and I encourage you to look there for more details. But I want to move on to the second research question, which is sort of about what is actually being submitted to this tip line, tip lines. Because all of the stuff that we looked at are nice, but what if all the content that is being submitted to these tip lines are just a spam or advertisements or jokes? And so it's really important to also see that the content being submitted to the tip line is the content that we want to moderate. And this is sort of what the second research question we studied pays attention to. Now, we specifically wanted to look at the images and the text messages that were submitted to the tip line. So here on this slide, you can see the three most popular images that were sent to the tip line, with the first one on the left being the most repeated one. And that image actually refers to a possible terrorist attempt, which was related to the election. And all three of these images are misinformation or contain misinformation. And so it's kind of a study to it's kind of difficult to study images, but in order to better understand the images that were shared to the tip line as a whole, we sort of created this visual summary of the images using clustering and visual embedding models. And then we took representing samples of each cluster and made this summary. So as you can see in the mosaic, there are some broad categories of images that were shared to the tip lines as we move from the top left to the bottom right. Pictures on the top left are images of text for the most part. And as you move towards the diagonal, you see that it's more of a mix of like images plus text. And so this could be memes, this could be quotes from politicians and infographics and so on. And then as we move towards the bottom right, we mostly see images of people. And to sort of give you a broad overview of like the dominant categories of the images. So the most dominant category was just images of text that's sort of made up 40% of the content. And then we had 35% of the images being memes. As for the text messages, a total of 89,000 messages were shared on the tip line. And after removing exact duplicate messages, we sort of clustered them to group similar claims. Now, I will get down to the details of like how we find similar textual claims in a few minutes. But to give you an understanding of what each cluster represented, each cluster includes only similar claims that are written in a variety of ways. So it's like one claim, eat alkaline foods if you want to prevent COVID, but written in maybe a few different ways and maybe a few different languages. And to sort of like take a closer look at these clusters, we hired an Indian journalist who actually had the experience of fact-checking during the 2019 election in India to look over the clusters. And we found that we found a total of 559 significant text clusters in these messages, 173 of which were election related. And equally so, 177 of them were sort of these tip line related queries that were mostly people asking follow-up questions on the content they had submitted, or like asking questions like, oh, I just found this on WhatsApp, is this true? And another interesting fact was that these sort of clusters of similar claims were not just in one language. They were up to 6 languages were found in the messages in each cluster. And most of the messages were in Hindi and English. And yeah, to take a closer look at the textual content, we also went through some of the larger clusters. We found that the largest election-related cluster is something we call the tender vote or the challenge vote story, which is actually misinformation. And this story was basically hinting that, other people could have voted in your place in the 2019 election. And, whenever you're going in to vote, you should ask for a tender vote before casting your vote. And that automatically, prevents fraud or whatever. And then the largest non-election cluster in the text messages that we looked at was, again, another false narrative, something we called the 3 blue check marks in the WhatsApp Messenger. And if you have used WhatsApp, whenever you send a text, if a blue check mark, if one blue check mark appears, under your message, that means that your message was delivered. And if two blue check marks appear under your message, it means that the person you sent the message to has read your message. And this interesting misinformation narrative was saying that the Indian government has actually implemented a third check mark, and if that ever appears under your messages, that means that the government has surveilled your text message. So watch out what you share, or you will end up in prison or something. And then we also looked at the major trends that sort of happened in these text messages, and they were very much in line with the stuff that were happening during the election. And the prominent themes were about Modi, the BJP party, and Rahul Gandhi, who was the most prominent contender of Modi in that election. And here are some more examples of the text submitted to the tip line. So like the example on the right is the challenge vote or the tender vote, or one version of that misinformation that I just talked about. And then the examples on the left and other examples included claims that are sometimes even accompanied by links and images as well. So to conclude the presentation for the first study, I want to briefly talk about some of the implications of our work. First, I want to point to the essential role of fact checkers in this study. Now, there were almost as many follow-up clusters of messages that people sent to the tip line to ask for updates on their queries as there were for the actual election-related claims that were submitted to the tip line for fact checking. And to be honest, we're not sure if the same content quantity and quality would have happened if this was only a flagging system with no fact checkers behind it. And so we want to emphasize that there is no guarantee that this intervention will work if fact checkers weren't behind it. And yeah. And sort of like, aside from the platforms, we think that three groups of people will benefit from such an intervention. So first, we think users will be enjoying a moderated community while their privacy is being preserved. And this service is also opt-in, so you can participate as much or as little as you want. Second, fact checkers will be able to discover content to check, and they will also be able to manage their content in a centralized way. So like all the good stuff that Scott showed a while ago, they get to sort of all have that. Maybe not all of it is because of the tip line, but they sort of provide and facilitate the way for that. And lastly, academics will get a new privacy respecting data source for research, like the data set that we released with the second study, which I will get to in a second. So the big takeaway from the first study for us was that tip lines are good for discovering popular content in a timely manner for fact checking. Now, I want to move on to the second study, which is actually from a paper we published together in the Association of Computational Linguistics conference in 2021. And I will talk in more details about sort of how we automatically match similar claims in a variety of languages, both high and low resource, to assist fact checkers and sort of increase their efficiency or the applicability of their work furthermore. So this work was sort of motivated by two observations. The first one being that, we've seen that one of the more reliable anti-misinformation efforts has been fact-checking. And when we say fact-checking, there's obviously this notion of fully automated fact-checking that has been a topic of interest within the AI and NLP community in recent years. But realistically speaking, we know that we will not have a fully functioning automated fact-checking pipeline anytime soon. And on the other hand, we have seen the value and the quality of human fact-checking, and we think it is very high quality and probably a viable solution. But it's just not as scalable. Like, how many people are you going to hire to moderate the entire internet or all of WhatsApp? Of misinformation is often repeated. So for example, in this slide, you can sort of it or not, these messages have been forwarded over 100 times to Midan's fact-checking partners from India to Brazil, and also in a bunch of different languages. And so this idea came to us that what if we could group all of these claims together? Basically, and I know that I'm skipping on a lot of these.
I think we're having a little connection trouble, Ashkan, and you're freezing a bit.
Oh,
You might be back now.
can you hear me well now?
Perfect. Yeah, I think we can now.
All right, I'm gonna start over a little bit. So I was just saying that I'm skipping ahead on a lot of detail, but sort of the classic way that these types of problems are solved in NLP are through the use of something called embedding models. And there are different versions of these models for different languages and purposes. And so for the task of claim matching, which we were interested in doing in a variety of languages and not just English, we sort of investigated or looked into a few state-of-the-art multilingual embedding models. And we particularly looked at Laser from Facebook and Lapsy from Google AI. And we found that they don't really work that well in low resource languages. And so like keeping in mind that we needed a solution that works for most languages and not a selected handful, we trained our own model, which we called Indian XLMR, or IXLMR for short, which is a new contextual embedding model to solve this claim matching problem. And then to sort of have a ground truth understanding of the task and also be able to evaluate our model as well as the existing models, we also developed 2 data sets in 5 different languages, both high and low resource. And one data set was on claim matching, which is the task that we are discussing, and another one on claim detection, which is given, a text message, does this message, contain claims that are worthy of fact checkers' times? And there's more detail on this in our paper, but I'm mostly going to be focusing on the claim matching aspect for this presentation. Now, let's talk a little bit more technically about measures of text similarity. So if you were to sort of like come up with an automatic measure for saying how similar 2 claims looked, obviously, one very basic starting point could be to just look at how many words they share and measure word overlap between them. And as you can see, there's some overlap between the 2 claims in this example. So, hot water, drink, and so on. But and the way this would work is that you count or you measure word overlap between the 2 claims, and then if the overlap is above a certain threshold, then you say these 2 claims are a match, and then if they are below the threshold, you say they're not. And so yeah, this is like a basic measure for text similarity. However, the obvious drawback of this method is that it's very syntactic, and it can only uncover surface level representation of meaning for both of the input claims. Now, for example, on this slide, you can sort of see that these 2 claims, so the claim on the left and on the right, are sort of different versions of the same misinformation narrative that, if you drink hot water or tea, it can cure COVID. But you can see that also these 2 claims almost have no word overlap. And so if you had used the previous similarity measure, this would have been one of the many examples that your system would fail in automatically classifying matching claims. However, if we had sort of a better, more semantic representation of words or sentences, then maybe we could sort of move beyond the syntactic level comparisons. So the way this is usually done in NLP is that you can maybe map words or sentences in a high dimensional space based on their similarity. So the more similar two words or two sentences or paragraphs are, the closer they will be mapped together in that high dimensional space. And so sort of as a toy example, you can see here that the words that are more similar in meaning, they are mapped in a two-dimensional space and closer together. And now if we sort of only look at the distances between these two claims or the words in these claims, and the distance, is less than a given threshold, then we can sort of come up with the same notion of matches and similarity and so on. And yeah, so this is the idea. This is the basic idea behind embedding models. And the first versions of them, which only operated on words, sort of like word2vec, came out a few years ago. And as you may know, AI and NLP have progressed a lot over the past few years. So there has just been a lot more advanced and complicated methods. And yeah, so the version of the problem that I've just described to you is a very, or is like the normal setup for the problem, but please note that we are only looking at this problem in one language, and that one language is English. And things do get more complicated when you want your model to work on different languages and also maybe across languages. So like the example here where the first claim on the top and the second claim are actually talking, again, about alkaline foods and COVID. And but the first claim is in English and the second claim is in Tamil, if I'm not mistaken. And so the same approach works, but the problem setting is a little bit more complicated, right? And so what we did for this study, because we wanted to be able to not only do this in one language, but in a bunch of different languages and, with different properties, especially, low resource and high resource languages, we found this method that allowed us to sort of extend an existing model for one language to a multilingual model if we had parallel translated text in both languages, in the source and the target language. And so if you do that, you can sort of get a nice multilingual model that perhaps could still map these two claims to the same points in the hyperspace. And again, you can sort of measure their distance or these two claims, M1 and M2, in the high dimensional space. And you can measure sort of the angle between the two vectors representing that. So to go back to our model IXLMR, for training it, we used the student-teacher approach, which was introduced by Reimers and Gurevich in EMNLP 2020. And as I said, this approach uses parallel data, both in teacher and student languages, to align and improve embeddings of the student model. So like I said, the core idea is that you want your student model to map sentences in that nice high dimensional space. You want your model to map sentences both in English and, in this example, Tamil, in pretty much the same, around the same vicinity. And once you do that, once your model can, learn these embeddings from the teacher model, then you can use the resulting student model and, use its capabilities both in English and Tamil. Now, again, there are more details on this, both in the EMNLP paper as well as our paper, but I'm going to sort of move on to evaluation for our models. Now, in order to evaluate this, we did a number of tests, and I'm going to mention two of them here. So the first test could simply be that, transform the input claims into two embedding vectors, and then do a simple binary classification test. How does the cosine similarity produced by these embedding models classify pairs of text for containing matching claims or non-matching claims? Now, if the similarity is above a certain threshold, like the example that we just talked about, the pairs of the text are a match and otherwise they're not a match. And to sort of like find that optimal threshold, we did tenfold cross-validation and then tested the threshold on a holdout set. And in this first test, we saw that our model, IXLMR, outperformed Laser and LabC, which were the state-of-the-art models for this task. Now, looking more closely at performance at different similarity thresholds, we see that IXLMR generally has higher recall than LabC and greater precision than Laser for any threshold, which sort of results in IXLMR having the highest F1 score across the thresholds. Furthermore, we were interested to see what if we add more information. And for the second evaluation, we wanted to add stuff like the length of the claims or the differences in length of the two input claims. And we also inputted the embedding vectors themselves, as well as the cosine similarity, which was already the input for the previous evaluation. And we wanted to see if just like adding simple features like this would improve the accuracy and the F1 score of our systems. And we found that it actually did. And we also saw that, again, IXLMR outperformed other state-of-the-art models. So before concluding the presentation on the second study, I briefly, again, wanted to share some thoughts. First, this is sort of an overlap between the previous paper and this one. So we were interested to see if a model is trained like this, if a model is trained the way IXLMR is, can it actually match claims across languages? Because so far our evaluations were only considering claims in one language. And so what we did was we clustered the tiplines, just like we did in the tipline paper. And we had an Indian journalist who spoke the languages in the data go over the clusters. And we found that 96% of the multilingual clusters contain similar claims in different languages. This isn't, by any means a very thorough evaluation, but we think that this approach has potential for cross-lingual claim matching as well. And we intend to study this further in future work. Finally, our claim matching system is currently being used by fact checkers in India and around the world to group similar claims and facilitate human fact checking. Although in this paper, we focus on Indian languages, our approach should extend to most other languages as well and can help scale global fact-checking efforts. So to sum up, we created and released 2 multilingual data sets. We also released or trained the model and released it as well, which works on a variety of high and low resource languages, and saw that it outperforms existing state-of-the-art models for the task of claim matching. I'm going to hand back the slides to Scott, as he will talk more about some research directions we have been taking with this work.
Thanks, Ashkan. Yeah, so, Ashkan's talked a lot about text. Certainly it's important. I would say it's probably about half the content that comes into tiplines right now, but roughly the other half in most places is probably images. So we employ image hashing to find similar images. And in some places, Brazil in particular stands out as an example. Audio and video material is quite prevalent and increasing. And so we also have developed, implemented audio hashing and video comparisons. Those work similar, but they're a little bit more difficult in that we basically have to shift them along and look because, of course, it may be a cropped version of one or a trimmed audio clip. If you're going to be working with video, we created a Python library that wraps some C++ code that Facebook AI produced for video similarity and hopefully makes it a lot easier to use that code going forward. Of course, there's also matches across these formats. And so we started performing text extraction on images and looking to see if that matches text. We pull the audio out of videos and compare it just to straight audio files. We transcribe both of those and compare them to text as well. And we're finding examples like this where misinformation is sort of remixed into these different formats. We want to keep improving our models. And so we're constantly getting feedback from users of Check when the model's unsure whether 2 items match each other or not. We ask our Check users for feedback. Here's a suggested match. Is it right? Click the green check mark. Not, click the red X. And over time, we can build better and better models and better data sets to improve the research in this area. And that's the last point that I want to conclude on, and then we'll have about 10 minutes for Q&A, which is to say that I think this area of misinformation response is one that's really ripe for more collaboration between researchers and practitioners. As researchers, there's just so much work that happens in English on Twitter data. And so I'm really excited to try to build solutions that allow us to create more data sets that go across platforms and across languages. Of course, from the practitioner side, whether it's fact checkers or community leaders, there's a real desire to be able to use some of the tools and insights coming out of academia, but it's just quite difficult to go from a paper or a GitHub repository to actually using that code in practice. And so the current direction that our work is taking is trying to build that collaborative infrastructure to enable fact checkers, community leaders, and academics to work together on misinformation response. And so this is a project recently funded by the National Science Foundation and the Convergence Accelerator to essentially try to build some of this. You've heard a lot about check and tiplines. We're reimagining tiplines. How could they be sort of the conduit through which we could send resources and self-help tips and sort of like empower people at the time that they're encountering this content, or community leaders are sort of seeing it in their networks. Alongside that, with industry and academic partners, we're thinking about how we can take the crowdsourced content that's coming through tiplines and join that together with large-scale content that's discovered algorithmically from the open web. And then, of course, as I mentioned, for the sort of academic side of this, we want to build that infrastructure for secure data sharing to make it much easier for fact checkers who are super busy, right? Don't have a lot of time, but we want to enable them to make it easy to sort of create and share data sets with academics. And conversely, to create the tools and resources for academics to say, well, look, if you put it in this sort of format or use this template, then it can immediately be pulled back and used by a fact checker or a community leader in practice. And of course, it's not just computer science and machine learning or whatnot. We need insights from all of the disciplines that everyone here is representing, be it the social sciences, communications, and humanities, and yes, computational methods as well. So this is just getting started, but I hope that in due course this may be a way by which you can collaborate and we can collaborate with practitioners and really make a difference to this. So with that, I want to close. I want to say a huge thank you, and I'll leave up some of these URLs in terms of the papers and a little bit more about that final project I mentioned. Thank you.
Thank you so much, Scott. Thank you so much, Ashkan. So we are now opening the floor for questions. You're welcome to put it in the chat, or you can also raise your hand. Start out with Matt. You've got your hand raised.
Oh, sure. Yeah, so great talk, really interesting stuff. One thing I got convinced on early is how bad the automatic methods are versus the humans, and why we sort of need to have them in the loop. But one thing that I heard somebody else say that kind of gave me pause in thinking about this was that if a fact check doesn't get out within 30 minutes to maybe an hour at most after something goes, that these beliefs become too entrenched. And human level stuff, at least on its own, will never get maybe there. And so, other than using methods to speed up the human fact check or human in the loop approaches, is there a space for fully automated approaches for doing something, some version of some kind of artifact that you get out there quickly, that we just acknowledge is not fully 100% whatever, but the quick thing we can get out there to potentially, keep people from starting to lock on to false news?
Yeah, I think so. And I'll take a first stab. Ashkan, feel free to jump in as well, probably in two ways. I mean, there are some structured approaches, maybe economic sort of claims and such, where you can actually create knowledge bases from statistics agencies, et cetera, and start working towards that. I know Full Fact in the UK, for instance, is doing some of that. I think the other option, an exciting opportunity, is sort of this idea of pre-bunking, right? Getting out in front of it. And for that to work, I think we have to move away from this sort of whack-a-mole of, oh, here's a new claim, address that one, address this one, right? And we have to start thinking more holistically about the type of misinformation that's there. And maybe there's a way to basically pre-bunk or inoculate people across a whole group of claims, right? By sort of saying, well, look, this is what we know about mask wearing and transmission, or, this is how we understand this relationship. And it can basically span a much larger set of claims than one at a time. So I think those two things can be really helpful with this. And then naturally, it is also this idea of media literacy and just, helping people build more critical skills to be aware of those techniques that by which misinformation tries to pass itself off as true.
Yeah, I would also add to that the social media platforms also play a role here. So, maybe one approach to also get ahead of this could be that if there's something posted on Twitter and it's getting a lot of traction and some people are saying it may be false, maybe you stop showing it to everyone on their feed, and maybe so that could be another approach to maybe stop the spread of some of these claims, fact check them first, and then start showing them on people's feeds. And that could be another effective way to sort of stop or to take action in that 30-minute time window.
So next, we've got a question in the chat from Aza, who asks, Scott, for audio, do you also include a sentiment analysis?
Yeah, great question. At the moment, our audio similarity is sort of at that syntactic level. It's like the word overlap that Ashkan presented. We're simply looking at, do the waveforms match? If we sort of shift them around, can we find a place where they're highly correlated? We do now transcribe audio as well for a number of languages, not all. So the great thing about syntactic overlap is it works, any language. It works for music even, just sounds. But yeah, we're moving in now is transcribing those. So possibility there. And yeah, I think there's a lot to be gained from sort of the use of pitch and other paralinguistic cues that happen in audio recordings. We're not there yet. I mean, I think there is research, but this is exactly why we need much more, I think, interaction with people across the spectrum doing research in these areas.
Great, thank you so much. Next, Greg, you've got your hand up.
Hi, yeah, thanks to both of you for the nice talk. So I guess this question is maybe a little bit more aimed at Ashkan, but I mean, you kind of showed the system with, sort of, I mean, showing some improvements over prior work and getting to, numbers that seem to be in like the 80% range. And it sounded like a lot of what you were looking at was like a binary classification setting of like, you've got some pairs that are the same and some pairs that are different. And I mean, it sounds like you've actually managed to get this working in practice. So I was curious about your experience kind of, I guess with respect to two things. The first is that like, a lot of times if you can binary classify an edge, it might still be the case that when you're trying to sift through like, 1 million claims and only like 500, 1,000 of them are duplicates or something, that 80% becomes tough to swing. And then also with respect to working it into the kind of human workflow. So I guess, can you talk a little bit about that deployment experience?
Yeah, first of all, I have to say that this was some of the experiments that I presented in the slides. We also looked at a retrieval-based type of approach to this. So the way that worked was that we first had like something simple, so like BM25, and then we refined the results using the embedding model. And I'm not super sure if I understood the question well, but if it's a concern about performance, then there are results from retrieval experiments that it shows that we are seeing good results on those experiments as well. And then does that answer the question?
Sort of. I mean, why don't you say what you were about to say, and then I'll see if I have a follow-up.
Yeah, I think that's it. Scott, would you add something to that?
Yeah, maybe I'll just add that you're right. I mean, these are highly imbalanced data sets, right? There's many more things that don't match than do. So even just constructing the data set and deciding what to send to annotators was a real challenge. And there's a whole probably another talk on how we did that. In practice, we've set the models to be a little conservative, if you like, because the way we're using them is essentially, new claim comes in, scan all the existing claims to see if there's already a close match to that. And we've tried to err on the side of caution a little bit. But we're also working on the sort of changes in UX. So what I showed in the tip line was sort of, oh, we have a fact check for that, yes or no. But now what we're thinking is, well, actually, we should really just push that back onto the requesting user and treat it more like Google search, right? More like the information retrieval problem that Ashkan was just referencing. And so now you send an item, or by the end of the month at least, you'll send an item to a tip line and you'll get back the sort of closest X matches. And then you can say, oh, did any of those match your query? If not, continue and submit that for further human consideration. If it did, happy days, we found something. And so I think, again, by having the sort of, in this case, the user on a social media platform in the loop with the machine, they can immediately give us feedback about whether there's a match there or not.
Okay, yeah, that was a great answer. That answered it. Yeah, thanks, both of you.
Great. I think I don't know if there's any other questions. I haven't seen any in the chat or any raised hands. So we're ending well in terms of time. Thank you both so much for the wonderful presentation. We really enjoyed hosting you.
Yeah,
Thank you.
Thanks so much. Thanks for having us.
Yeah, and we'll be very happy to to follow up. And if questions occur to anyone afterwards or anyone watching the video, please reach out. And yeah, we're very excited to find more collaboration opportunities and work together. So thank you.